Good morning, guys. Hope you're doing well. So yesterday I made a mistake, which those words have become like some kind of mantra from me. Sorry about that, guys. But yesterday I made a mistake in telling you that synthetic division is exactly the same thing as long division. So synthetic division is a shorthand of long division, which uses only the coefficients of both the polynomial and the divisor, only the coefficients. In order for synthetic division to work, the coefficient of the divisor has to be 1. It has a coefficient of 1. And this divisor has to be of the form x minus k. So being of the form x minus k means that if it is x minus 3, then the k value is positive 3. But if it was x plus 1, for example, and then I compare that with x minus k, then the k value would be 1. I'm going to explain what that means in a second. So, reminding you of long division. Long division, when we did this, it was 5x squared minus 3x minus 36. And you divide that by x minus 3. The first step we did was 5 divided by 3, 5x squared, divided by x is 5x. And 5x times x is 5x squared. Then 5x times negative 3 is negative 15. Now, one of the disadvantages of long division is that you're repeating a lot of steps. You're multiplying 5 by x, and then, you're dividing 5x squared by x, and then again you're multiplying 5x by x. So that looks like a redundant step or like an unnecessary step. And what synthetic division does is it takes out a lot of those redundant steps. And I'll show you what it looks like. So again, just recapping, long division, when you subtracted 5x squared minus 5x squared, you got 0. Negative 3 minus negative 15x, this was 15x. Negative 3 minus negative 15x, that gives you positive 12. The 36 comes down because technically 36 minus 0 is negative 36. Then you'd repeat the process. 12x divided by x is positive 12. Now I've just divided, and again I'm going to multiply again 12 times x, and I get 12x. So it looks like again a redundant step. And then I'll do 12 minus 3, 12 times 3, negative 3 is negative 36. Then I'll subtract and get remainders of 0. And I can finally write that my polynomial f of x, which is this f of x, is the same thing as x minus 3 multiplied by 5x plus 12, since I have no remainder, plus 0. Or I can say f of x over the divisor x minus 3 is the same thing as 5x plus 12. So that's long division. In synthetic division, remember, just to clarify, it's the shorthand of long division. You're doing the same thing practically and mentally, but you're getting rid of a lot of unnecessary steps, which reduces your likelihood of making errors. So what you do is write out the coefficients of the polynomial, but be sure to write them out in descending powers of x. So if this is 5x squared, the coefficient is 5. If this is 3x, the coefficient is negative 3. I'm saying descending powers of x because sometimes you'll have polynomials that do not have some powers represented. So a polynomial like this, it has a power of 4, but it doesn't have a power of 3. It doesn't have a power of 1. So its coefficients would be 5 for the power of 4, 0 for the power of 3, 2 for the power of 2, 0 for the power of 1, and 4 for the power of 0, x to the power 0. So don't forget these ones because these correspond to powers of 0, and you have to write it in descending powers of 0. This polynomial that I'm doing here is fine because all the powers are represented. I have x to the power 2 and x to the power 1 and x to the power 0. So their coefficients are 5, negative 3, and negative 36. Use the upside down division symbol. Leave a little bit of space under the coefficients because that's where you're going to write some information there. Next is find out what the k value is, and the k value will go here. The k value, since I'm comparing x minus 3 to x minus k, I can see from that that the k value is 3. So I'm dividing the whole thing by 3. Again, this is a shortcut. It's synthetic division, a shorthand of long division. So in case you're wondering why I'm ignoring the x, it's because I'm only using the factor x minus k and I'm using the constant part of that factor, and then on the inside I only use the coefficients. So the first step is to get this 5 and bring it down under the division symbol, and then say 5 times 3, that gives you 15. Write it under the next value. In these columns we're going to add. I'm going to add in these columns. In this column we add, all the columns here we add. So then you do negative 3 plus 15, which gives you positive 12. Then you repeat the process. 12 times 3 is 36. 36. This was 36 because the coefficient was 36, sorry. 12 times 3 is 36. In this column again you add, so negative 36 plus 36 is 0. Once you get a 0, you know that your remainder is 0. Because 0 times 3 is still 0, and even still I don't have any other coefficients here to still keep going. So I've finished my division really, because this shows me that this term has a power of 0 and this term has a power of 1. So this is going to be 5x plus 12. So I've finished to get my quotient. It's already 5x plus 12. That's my quotient. I hope you can see that this is much faster than long division. And I'm sorry again, I made the mistake yesterday to tell you that it's the same thing. It's not the same thing, it's just a shorthand, and you're doing the same thing, but it's a shortcut or a shorthand. So that's what synthetic division is. I'm going to do one more example for you. The next one, which I think I had asked you to do on your own. Again, I'm going to pick out the factors, the coefficients. Pick out the coefficients. So negative 9, that's for x to the power 4. Positive 10 for x to the power 3. Positive 7 for x to the power 2. Since this polynomial doesn't have an x to the power 1, its coefficient is 0. And then negative 6 as the last one. I'm dividing it by x minus 1. Compare that with x minus k. You can see that the k value is 1. So draw your symbol for upside down division. Put the k value of 1 here. And then first step is bring this first coefficient down here, negative 9. So negative 9 times 1, that gives you negative 9. Remember, in these columns we add. In these columns we add. So 10 plus negative 9 is a positive 1. Positive 1 times 1 is a positive 1. Write that under the next column. And then add the column. 7 plus 1 is 8. 8 times 1 is 8. Write it under the next column. And then add this column to get 8. 8 times 1 is 8. Write it under here. And then add. Negative 6 plus 8 is 2. This tells you that your remainder is 2 because the last number you get in this position is going to be your remainder. So remember, I know that since the biggest power of the polynomial was x to the power 4, when I divide, the next power has to be x to the power 3. This is x to the power 2. This is x to the power 1. This is x to the power 0. And then this is the remainder. This is the remainder. So my quotient, because the quotient is also a function of x, is negative 9x cubed plus x squared plus 8x plus 8. That's my quotient. My remainder is 2, so I can write my original f of x divided by x minus 1 as the quotient, which is negative 9x cubed plus x squared plus 8x plus 8. This was a positive, not a negative, plus 2 out of x minus 1. That is what synthetic division is. I hope this is helpful. Again, sorry that I misled you, but I hope you can adjust or adapt. Yeah.